everyone, my name is Syeda Iraj Jamshed and welcome to Engineering by Default, where we dive deep into engineering marvels, innovations, and disasters. Today, we will be discussing one of the most tragic industrial disasters in history, the Piper Alpha oil rig disaster. The Piper Alpha oil platform, discovered in January 1973, was one of the first deep-water reservoirs to be exploited in the northern North Sea. Production began in December 1976, and with growing demands, modifications were made to export gas starting in December 1978. On July 6, 1988, at around 9:45 p.m., a condensate pump on Piper Alpha tripped. By 10 p.m., an explosion rocked the platform in Module C, the gas compressor module, triggering a chain of events. A condensate line ruptured, followed by multiple gas line ruptures connecting to other platforms. As you can see the modules here. The gas line from the tartan platform ruptured 20 minutes later, followed by another rupture from a total operated line at 10:50 p.m. The final rupture came at 11:20 p.m., linking to the Claymore platform. It took over 3 weeks for the fire to be extinguished, with the remains of Piper Alpha ultimately being toppled into the sea on March 28, 1989. Technical investigations revealed that on the evening of July 6, condensate pump A had been isolated for maintenance, its pressure relief valve was removed, and a blind flange was fitted in its place without proper testing. When pump B failed, operators unknowingly attempted to restart it, leading to the explosion. Hyper Alpha disaster taught us valuable lessons about safety management, the importance of clear communication, and the need for robust emergency response systems. Among the key points: management of change, person safety over process safety, permit to work systems, and maintenance isolation, effective shift and handover. The platform's design also posed a major risk. The decision to export gas was an afterthought, leading to extensive modifications. This resulted in gas processing facilities being located dangerously close to the control room and other key operational areas. As you can see, the design flaws here our critical oversight was the manual operation of fire water pumps, a practice followed for years to protect divers. This delay in activating fire suppression proved disastrous when the first explosion occurred. So, the coolant raised serious concerns about. Four questions were asked. Was the procedure adequate? Was the procedure complied with? Was there adequate training? Was the procedure monitored? In all cases, the answers were no. Poor communication between shifts and departments played a key role in the disaster. One of the critical failures during the Piper Alpha disaster was the breakdown in communication. After the first explosion, contact with the other platforms such as Tartan and Claymore was lost. This delayed the shutdown of those platforms, allowing oil and gas to continue flooding the rig. The lack of immediate action contributed to the severity of the fire, leading to the further explosions. This highlights the importance of maintaining communication lines during emergencies to prevent such cascading failures. Within a minute of the first explosion, the helideck was covered in black smoke, preventing helicopters from landing. Safety systems on the nearby Tharos platform, though advanced, had never been tested in such extreme conditions and ultimately failed. In the year before the disaster, a warning came when a contractor was killed on Piper Alpha. The accident exposed flaws in safety management, but the golden opportunity to address these issues was missed. The Cullen Inquiry placed the primary responsibility for safety on those who create the risk. It emphasized that safety management systems must be continuously audited and updated, ensuring they work in practice. While the exact cause of Piper Alpha disaster remains unclear, it highlighted serious design flaws and gaps in safety management. This tragedy reminds us that technical measures alone are not enough. We must also foster a culture of safety that spans the entire life cycle of a project. Thank you for watching. If you found this topic insightful, please like and subscribe to Engineering by Default. Let's continue to explore the world of engineering.